Hello, my name is Mireia Yurrita. I'm a PhD student at TU Delft and a Marie Curie Fellow at the Code Network. Along with my colleagues Dave Murray-Rust, Agathe Balayn, and Alessandro Bozzon, we wrote a paper called Towards a Multi-Stakeholder Value-Based Assessment Framework for Algorithmic Systems, which I'm very happy to present. So in recent years, algorithmic systems are developed and deployed for decision-making processes in areas such as healthcare, education, or recruitment processes. Some of these algorithmic systems have been proven to encode biases, going from racial biases to gender biases. And they have also been proven to favor, in some of those cases, very specific parts or groups of the population. So for instance, in the case of the UK, they were using an algorithm to estimate the exam results, and it was proven that the calculations favored elites. So in response to these problematic machine behaviors, problematic outcomes coming from the usage of algorithmic systems, there has been a great amount of work in recent years for ensuring that algorithmic systems are developed in an ethical way. So among those approaches, and in order to facilitate the audit of ML-driven systems, it is important that technical specifications are collected and documented in a standardized way. That is why standardized documentation practices have been developed in the last years. So those include documentation practices for datasets and documentation practices also for models. When it comes to auditing techniques, influential methodologies have been developed for dealing with harmful algorithmic bias. Basically, as part of the current auditing techniques, harmful algorithmic bias is detected, is identified, and there has been a research stream for developing tools for debiasing those algorithmic systems in pre-processing, in processing, or even post-processing stages of the machine learning pipeline. In the paper, we argue that auditing techniques have been very influential. They have been very impactful and very effective when dealing with harmful algorithmic bias, but their scope is limited to performing quantitative analysis over data and model outputs so as to ensure that they comply with applicable standards. But these auditing techniques do not deal with most of the ethical values that are outlined in ethics in AI documents, which are very difficult to quantify, but still are essential for ensuring that the algorithmic behavior of the systems that we are shaping is desirable. The problem with ethical values or ethical principles for ML-driven systems that have been suggested by public and private organizations in the last years is that these ethical principles are still very high level and they are very difficult to operationalize. So we address the limitations of current auditing techniques and the ethical principles in the following way. So first of all, we create a review of values, which is guided, and we arrange these values in a geometrically meaningful way so as to guide the assessment process to make sure that we are not limited or we are not limiting the scope of the assessment process to dealing with harmful algorithmic bias, but we think of harmful algorithmic behavior instead. So we create this guided review of values, and then we operationalize these values into criteria and manifestation so as to deal with the problem of ethical principles for ML-driven systems being too high level and difficult to put into practice. Since there are some value trade-offs between the values and ethical principles outlined in the assessment framework, and there are even some value-specific criteria that are mutually exclusive, we advocate for diverse standpoints, and we want to enable multi-stakeholder deliberation and negotiation of those value priorities and tensions. And that is why we map not only the stakeholders that should be part of the deliberation processes, but also we also map the communication means that are currently available and that are tailored to the insight needs of each of those stakeholders. So let me introduce the values first of all. So we decided to arrange the values outlined in ethics in AI documents in a geometrically meaningful way, so that adjacent values denote common motivations and opposed values denote potential trade-offs between values. So that is why we arrange those values in a circular way and also in two bipolar dimensions. So the first dimension deals with the trade-off between conservation and openness. The dimension of conservation includes values that uphold confidentiality and robustness. That is to say, privacy, security, and performance are the values that advocate for this kind of confidentiality and robustness properties of algorithmic systems. Whereas in the dimension of openness, we want to include the values that advocate for making system components and specifications accessible. So those include transparency and explainability. The second dimension deals with universalism versus individual empowerment. Values included as part of the universalism dimension advocate for the need to ensure equitable and socially acceptable system behavior for all. That includes respect for public interest, fairness, and non-discrimination. In the case of individual empowerment, the values that are classified as part of this dimension are those that defend the decision subject's interest. Those include contestability, human control, and human agency. So as you can see, these values have been classified in or arranged in a geometrically meaningful way. So let's move on now to a motivating example so that we can illustrate the assessment process for an automated life insurance application process and make those values, high-level values, more tangible. So let's imagine that we want to build an automated life insurance application process. We are part of the development team, but we want to do it in an ethical way. So the data that we're going to use for making the predictions will be physiological information, details about employment, the insurance history of the applicant, and individual and family medical history. So in order to start the assessment process, we will pick just two values that are opposed to each other so that there is some trade-offs. There are some trade-offs there that we need to negotiate. Of course, the assessment process itself should include all of the values or even additional ones which are specific to this context. But in order to limit this example to the length or adapt it to the length of a conference paper, we just chose two. So as we can see, they are arranged in opposing dimensions, which already denotes some potential trade-offs. We will then break these values down into criteria and their manifestations, among which there is a many-to-many relationship. So when it comes to privacy, and based on literature, the criteria that define the value of privacy are consent for data usage, data protection, control over data and ability to restrict processing, right to rectification, right to erase the data, and right of access by data subjects, that is to say, data agents. So these criteria are then manifested through either signifiers, which are colored in orange in our paper. If they are green or olive, then they are process-related practices. And if they are magenta or pink, that means that these manifestations are quantifiable indicators. So in the case of privacy, privacy is manifested through written consent, description of what data is collected, how data is handled, and how long the data is kept, a purpose statement, form and submission mechanisms to object data collection and to make complaints, and the obfuscation of data. When it comes to explainability, explainability is defined using the following criteria: ability to understand AI systems and the decision reached, traceability and explainability means should also enable evaluation. So when it comes to explainability, explainability is manifested creating an algorithmic system that is interpretable by design, or creating post hoc explanations for this kind of systems. So we can already see that when it comes to post hoc explanations, especially explanations which are based on examples taken from the training data set of those algorithmic systems, the data protection criteria that defines privacy might be conflicting with the usage of post hoc explanations, especially in the form of examples from the data taken from the training data set. So these are the kind of trade-offs between values that we want to make sure that are negotiated in a multi-stakeholder fashion, taking into account a diversity of standpoints coming from different stakeholders that are somehow involved with the usage or development of the algorithmic system. So let's move on now from the criteria manifestations to the mapping of stakeholders, so that we can then assign them tailored means for communicating manifestation and value-specific information to those stakeholders. So when it comes to stakeholders, the development team, the auditing team, the medical and life insurance team, that is to say data domain experts and decision subjects, should be part of the assessment process according to our viewpoint in the paper. So each of those stakeholders presents a very diverse knowledge, going from the knowledge of the math behind the architecture to theories relevant to the data domain when it comes to the data domain experts, for instance, and they also have a different purpose for insight. So the development team wants to ensure that the product is efficient and wants to be able to debug their product, in this case, the algorithmic system. But the decision subjects might be more interested in knowing and verifying that the decision that they're getting is fair, for instance. So based on this nature of knowledge, like this insight needs and the purpose of the insight, we decided to map currently available communication means to the needs and purposes of each stakeholder. So I will just give the example of privacy dashboards, but if you check the paper, you will see that we mapped each value and their manifestations to currently available means for communicating system-specific information based on the knowledge and the insight needs of each of the stakeholder. So those communication means could be documentation practices, could be ready-to-use tools, or design strategies. In this case, green means ready-to-use tools, and privacy dashboards are just one example of those communication needs. So of course, we know that there are some limitations that need to be taken into account when using our assessment framework. So first of all, we did not include accountability as a value per se. There are some design choices that we had to make, and we decided to focus on the machine behavior and characterizing values related to machine behavior, rather than the people who in each case are responsible for potential pitfalls. That is why we did not include accountability as a value per se, although we know that there needs to be a specification of who is responsible, who is accountable for potential pitfalls, errors, or unfair behaviors coming from the algorithmic system. There are also some shortcomings of pre-selecting values, and that is why we do not claim our methodology to be universal. And the methodology that we presented, our value-based framework, is open to situationally specific versions of the framework itself. We also acknowledge that there might be some differences between value alignments and tensions due to context, and this requires to check the usage of the assessment framework in different contexts so as to ensure consistency. And there is also a need for standardizing these kind of practices. So we think that our assessment framework should be part of a broader evaluation workflow, and that there is a need for standardizing these kind of practices. So that is what I wanted to present, and I just hope that you found this interesting and insightful. Thank you very much.